Including mg and n.
Yes, let's include mxg and the normal reaction. Apart from this, what's the other force?
F.
So the F is acting on Y, not on X. So you will not show it here. This is the free body diagram for X.
So there would be just a force acting on X though.
Let me draw the Y. So observe for Y, let's draw the mg downwards, normal reaction upwards. And that external force F is acting on Y, not on X. Right? So, okay. So now what else? What do we do? Okay, Ahan, tell me any other force acting on X?
Well, because y and x are in contact, y will be pushing x.
Exactly. Y is pushing X. So you will show a force. Let's call this as P. Let's say P is the push coming from Y. Okay, now according to the Newton's third law, there should be another P somewhere. Where is the second P?
X pushing back on y.
Yes, X pushing back on Y. So this is this P. Right now, if you look at option B, it's saying the force that Y exerts on X. So the force which they are talking about is this force P. And according to the option P, B, P is less than F. So how do we prove that, Ahan? P is less than F.
Uh, so because F is not being balanced anywhere wherein this P is,
Okay,
right?
great. Apply the Newton's second law for this, the combined thing. What will be the equation?
The whole mass into acceleration is equal to F.
F is equal to total mass into acceleration, right? Now, if
Yeah.
you apply the Newton's second law only for X, what will the equation look like?
Uh,
For X, what's the net force? See,
F.
weight and normal reaction, they always cancel out. So the only remaining force is P.
Yeah.
So net force is P, and that will be equal to mass into acceleration. Right?
Uh,
So P is equal to mxa. Let's make A as the subject from this first equation. We will get this and put the value of A in this. It's a tricky question. Write this down. Okay, so write till this step and see, can we deduce that P is less than F?
yeah. Yeah, fine. That's a really long process though.
Hmm. But your logic was also correct. That was more conceptual. So, Anushka, just tell me, is it making sense what we have done here?
Yeah, sir, understood.
Okay. So, option B, anyways, which you selected earlier. But see, why I explained all this is in some other questions, you will be expected to draw the free body diagram separately. So, these two diagrams are important when you draw forces separately. Makes sense, the separate free body diagrams.
Yeah.
Okay, fine. So we'll do one more question for today.
So could we also do pulley systems? I don't really understand them.
Okay, pulley system means the elevator questions.
Yeah, sometimes they ask this block
Oh,
is kept on a
okay.
frictionless surface and then
We'll do that. In the meantime, solve this. Let me find a pulley question.
so it is it mg minus ma.
Let's see. Let's wait for Anushka. Anushka, solve.
Yeah, sir. Mg minus Ma.
Mg minus Ma. What's the logic?
From what we did earlier,
Mm-hmm.
if it's accelerating downwards, that
Mm-hmm.
means the force meter would show a lower value than mg.
Correct. Good. That's the right logic. Okay. So one last question for today. That's on graph. And Ahan, let me find the pulley questions. We'll solve that tomorrow.
Okay, sir. So tomorrow, what chapter are we doing?
One sec, one sec. Let's finish the last question and then we'll discuss. Okay, here we go. Try this.
So does it C?
Explain.
So power over time would basically, you would be considering acceleration by time.
Okay.
And so if,
One second, Anushka. Let me read the whole thing.
yeah,
Straight track, moving from west, constant acceleration. The horizontal forces acting on the train are the engine force and the resistive force. The resistive force increases with speed. Which graph represents the variation with time of the power developed by the engine? Okay, so Anushka, tell me.
so if you would take this similar to say terminal velocity,
Mm-hmm,
as the train's speed is increasing, the
mm-hmm.
resistive force is also increasing, hence
Perfect.
the acceleration would decrease while the speed is still increasing.
True, correct. That's true for
Sir,
that case, Anushka. But in this, they have also given you
constant.
additional information.
Sir,
For
is it
Okay.
acceleration, repeat.
is it D?
Let's see. The net force is the engine force minus the resistive force, and that is equal to ma. Now, Anushka, acceleration has been given a constant. Net force is a constant, which means if your resistive force is increasing, your engine force correspondingly has to increase. Anushka, check.
Okay,
Makes
sir.
sense,
Yeah.
right? So if the engine force has to increase, then you use the power formula. Power of the engine is force into velocity.
Yes, sir.
So what will happen to power? Is it increasing or decreasing?
It will increase.
It will increase. The increasing options are B or D.
Oh, okay, okay.
But now, why D and why not B?
Sir, it can't be linear at all if there's a resistive force which changes with velocity. The
Hmm,
engine would need to quite literally exponentially produce
correct.
power
Good.
with
Yes,
constant acceleration.
it is D. It cannot be linear in this case. So, Anushka, the only key word here was constant acceleration.
Okay, sir, got it. So if this was the example that I gave, then C would have been correct, right?
Yes, correct.
Okay.
So that is the case when somebody is on free fall, falling towards the earth.
Yeah, sir.
That's terminal concept. Okay, so we have done basic revision on mechanics today. Wait, let's see. Let's solve waves tomorrow. Will that work, both of you? Because
Yes.
see, I'll tell you the most important chapters for HL. It's mechanics, chapter 2, waves, electricity and magnetism, wave phenomena, and electromagnetic induction. These are the 5 most important chapters. So okay, so both of you please revise everything on oscillations and waves. We will solve questions tomorrow.
Yes,
Okay,
sir.
sir.
Chalo. And same time, 4:30.
Okay, sir.
Okay, sir.
Bye-bye.
Thank you.
Bye, sir. Thank you.